Okay, so this is our section over earthquakes and volcanoes. This should be your second section for the Google Classroom. We're going to talk about what causes earthquakes, uh, where do they most often occur, how do scientists actually learn about earthquakes, and what does it tell us about the Earth's interior, and then also what's a volcano and the different classifications of volcanoes as well. So first off, what are earthquakes and where do they most likely occur? Earthquakes are going to occur mostly at boundaries of plate tectonics. So we, in the last section of notes, briefly looked over those boundaries, those different type of boundaries. We have convergent, divergent, and transform boundaries, and so those are the areas where these earthquakes will most likely take place. Um, and how those plates move in respect to each other is actually going to be what causes a big earthquake versus just a smaller classification of earthquake as well. So they occur at these boundaries. Earthquakes are just going to be vibrations that result from rocks sliding past each other at their fault. And what these vibrations will do is they will actually send out what are known as seismic waves. And these waves are going to be waves of energy released from that center point of the earthquake or where it takes place. There's two different terms for that location. The focus is going to be the location within the earth that is along that fault uh, down in the layers of the earth. And this is where the actual slippage or the collision of the plates took place, generating that energy and causing the earthquake to occur. Up above on the Earth's surface is known as the epicenter. Okay, that's so that scientists can actually relate that position to maybe a town or a place here on the Earth's surface, so that it's more easily to identify the location for us that live on the crust. Okay, so you can see in this picture here, down in the actual plates where the collision of the plate or the slippage of the plate took place. That's known as the focus. And then up above, whatever that location would be, maybe there's a town nearby, we would relate that to the epicenter. Okay, so those two terms you usually hear with a lot of earthquakes. Here in Kansas, we have some earthquakes that usually take place in Oklahoma. In the last couple of years, that's where most of ours have generated from. And we usually identify, once again, where those earthquakes are, wherever the nearest town would be, or what town is nearby that epicenter. And so that's how we'll relate those. Okay, so what are earthquakes? It's going to be energy that is going to be transferred by those waves through the rock. And so what we know from that is those waves will actually travel, and the energy that is released from the earthquake is going to measure as shock waves. There's three different waves that generate from earthquakes. We have our longitudinal waves, which are called P waves. We have transverse waves, which are known as S waves, and then we have surface waves. Those three waves, we'll talk a little bit more on the next couple of slides, more in detail about those. But our P waves stands for primary waves. S wave stands for secondary waves. And so you also may hear those terms as well on the next couple of slides. So longitudinal waves, also known as primary waves or P waves, will actually travel by compressing and stretching the Earth's crust. And so what happens is it will move more, I guess it would be on the x-axis than anything else. We'll show that on the next slide. Transverse waves are going to be secondary waves, and they come second, or we feel those second in comparison to the primary waves. They will travel more up and down, so more on the y-axis of the movement of the waves. So when we relate these two to each other, we call the longitudinal waves primary waves because these are the first energy waves sent out from the earthquake. They travel faster and they reach other destinations first. The transverse waves or the secondary waves are the ones that hit second after that. So you can see here with our three classifications are P waves. It's almost like if you had a slinky, stretched it out, but then pulled a little bit back, and it would move along the x-axis as it travels, compressing and stretching the Earth's crust. S waves are going to be a little bit more violent. They're going to move more up and down along the y-axis. But then the worst of all is going to be the surface waves. The surface waves are going to be moving both horizontally and vertically and cause a lot of damage. So both are P and S waves spread out from each other or from the focus in all directions throughout the Earth's surface. Surface waves only move on the Earth's surface. They do not go through the different layers of the Earth. And that's why those P waves and those S waves will actually reach a different location first, is because they can actually travel through the Earth's crust and its mantle, and even the core and outer core and inner core. Surface waves can only travel on the surface. And so therefore they cannot go into the mantle and the core below. So how do we measure our earthquakes and these waves that are sent out from the earthquakes? Scientists can actually measure the waves in order to learn about the earthquakes in the interior of the Earth's surface, which allows for the waves to travel differently from each other. The compressing movement versus the vertical movement versus the surface waves, which are a little bit of both. In order to study our earthquakes, we call that study seismology. Okay, so studying the origin, where the earthquake took place, its propagation, and then the energy, and then that's sent out from those earthquakes, and then also being able to predict where earthquakes may take place. Seismologists, or the scientists that study seismology, are going to detect and measure earthquakes. And what they use in order to do that is what is known as a seismograph. A seismograph is used in order to record the data of the earthquakes, and what it will give us is what is called a seismogram. Okay, so seismographs give us seismograms. And here's what that looks like. So what we have within the Earth's surface, we actually have these centers set up already. It's a big spool of paper and a pendulum that has ink in it. Okay, and all this thing does is as the Earth begins to vibrate and move back and forth, it records those vibrations with those little pens that they have. And so the more violent a vibration is, the more violent that movement of back and forth will be on that seismograph. And we can study those lines on the seismograph in order to determine the energy that that earthquake gave out, and then also the energy that those different waves have. So what you'll see on that is here's what that will look like on a more abbreviated picture. So what you have first is usually your P waves. Remember, those are the first or the primary waves that hit a location. Slightly after that, time-wise, will be then the S waves, which are a little bit more violent. You can see the movements are a little bit bigger, but then the surface waves hit after that. You can see there's very violent moving back and forth on the seismograph, and those come third or last of all the different waves. So P waves are usually a little bit smaller, S waves are a little bit bigger, and then surface waves are even bigger than that. In order to locate the epicenter of an earthquake, we need 3 seismograph stations in order to do this. We know that scientists actually set up over 1,000 different seismograph stations across the world, and we use these 1,000 seismograph stations in order to measure the energy sent out by certain waves. And as long as we have 3, those 3 can overlap and give us a location of the epicenter of where that earthquake originated from. Because our P waves move faster, the difference between the P wave and the arrival of the S wave allows for our scientists to actually calculate how far away that focus would be, or how far away the origin of that earthquake would be from those stations. So geologists will use these seismographs in order to investigate the Earth's interior. The way the P waves and the S waves travel through the Earth's interior has allowed for scientists to actually make a model of what that interior looks like That's actually how we came to know the core to be, or the outer core to be liquid metal, and the inner core to be solid metal, because of those waves and how they travel through those two different regions. In order to classify our earthquakes and the amount of energy that they send out, we use what is known as a Richter scale. A Richter scale gives us a number 1 through 12, and this expresses the magnitude or how violent that earthquake is. So the higher up the number is, the stronger the earthquake would be within those regions. So you can see here, here's a little graph showing the magnitude. And this is actually going to be tenfold times. So a number 9 on the Richter scale is going to be 10 times stronger than an 8. And as you go lower, same thing, 10 times stronger at each level. So down here would be minor Richter scales or minor earthquakes. Up here at the top would be more major ones that cause a lot of damage. And just to show you kind of what that would look like, once again, smaller intensity would give us very little damage. You may not even feel it. As a 1, 2 to 3, we get a lot of 3s and 4s here in Kansas. But then once you start to get up to 5, 6, and 7, there can be extreme danger that takes place, and above that. Here's a link if you want to go check it out, explaining a little bit more about the Richter scale. Other factors can also affect the severity of an earthquake, such as distance. So if you're further away from the earthquake, it's not going to be as violent. And then also local construction techniques. Here in the United States, we have probably the best infrastructure for construction. And even in California, they're developing techniques in order how to allow for more swaying in the building, so that there's less collapsing of buildings when earthquakes do take place. However, not every country is as fortunate as us, and so therefore there's going to be those with lower construction techniques usually have more severity in their damages. Okay, so we'll stop there for today. Go ahead and fill out that section over earthquakes. We'll talk about volcanoes tomorrow. Thanks.